Alright, these are our notes on section 3.3 on slope. We're going to go get started. Slope is, the formal definition is the change in y over the change in the x values. Now, the way that you've probably seen it is rise over run. That's the most common. And the letter we use for slope is m. So it'd be m equals however far up and down we're going, that's the rise part, over however far left and right we're going. Okay, so this is up, down, on top, and on the bottom, it's left, right. Now something to remember before we get to our example over here with our picture, something to remember is that up and right are positive values. We're going in those two directions, those numbers will be positive because that's where the positive numbers are located. As we count up on the y-axis, the numbers get bigger, they get more positive. As we count to the right, the numbers get bigger and they get positive. That means down and left are negative. Alright, so if we look at our picture here, we have 2 points on our line. Doesn't matter which point we start with, but I'm going to start here at this one. We're going to go from one point to the other, and we're going to count how far up and down we go over how far left and right. So we got to go up, and then we have to go over to the right. Well, we went up 2, and we went right 1. So that would mean that our slope, remember up is positive, so it would be positive 2 over, then we went to the right 1, right was positive, so the bottom is 1, and that's going to reduce to 2. So our slope for this line is 2. Now I said it didn't matter which one you started at. If we start at the other point and we go down and then to the left, okay, we would go down negative 2 because we're going down, it's got to be negative. Then we're going to the left, so it would be negative 1. Negative 2 over negative 1 is going to reduce to 2. We get the same answer. So it doesn't matter which point you start with, you'll get the same answer. Just remember that up and to the right are positive, down and to the left are negative. Now that's what we'd use if we had a picture. You could count it very easily. If we don't have a picture, you could do one of two things. You could graph your points, which may take you some time, or you could use the slope formula. And your slope formula is y2 minus y1 over x2 minus x1. Remember, we set up in our definition that it was the change in the y's, that's why y's are on top, over the change in the x. So there's our formula. And then x1, y1, and x2, y2 are just points that we come up with, that they give us. They're both on the line, but notice that in the first point, it's x1, y1. It's not x1, x2, those two don't come from the same coordinate pair, or ordered pair, from the same point. It's one x and then one y, and then the second point has the other x and the other y. So we're going to do an example here. We've got negative 2, negative 4, and 0, 9. Those are our 2 points. I'm going to write on here x1, y1, just so that I remember, and then x2, y2. That will tell me when I plug my numbers into my formula where I'm getting them. It will help me remember them. So we would say m equals, well, our formula is y2 minus y1 first. There's y2. 9 minus y1 is negative 4. So it's minus a negative 4 over x2 is 0 minus a negative 2. We're going to simplify that. Now when you have two negatives together, remember they become a positive. You same add reverse. So it's really 9 plus 4, which is 13, over 0 plus 2, which is 2. So our slope is 13 over 2. And that's it. That's all we have to do. We're done. I'm going to give you a pause and practice problem here. Pause the video, work the problem out, and check and see if you get the same answer. Okay? And your points are 7, negative 3, and 6, 10. So go ahead and pause it, work it out, and then come back and check your answer. Alright, now that you've had a chance to work it out, let's check your work. Let's see if you got the right answer. We start with m equals x1, y1, x2, y2. Let's plug in our values. y2 first, minus y1. So we've got 10 minus a negative 3. I'm going to go ahead and change those signs right now. You can do it later, but I'm going to change it first. On the bottom, we have x2, which in this case is 6, minus 7. Notice it's not a negative 7, so I'm not going to change my sign at this point. It's going to stay 6 minus 7. Let's simplify that. 10 plus 3 is 13 over 6 minus 7 is negative 1. That's going to reduce down to negative 13. And there's our slope. So if you got negative 13, you did it correctly. If not, go back and change it so that you know where you got the answer and see if you can find your mistake. See if you can correct your mistake. Now we got a couple other important things to remember here. I got another example. We're going to work this one out together. It is 2, negative 4, and 2, 8. You should notice something right here. The 2's are the same in both of those, and that's going to be important. That's one thing I want you to see. Let's go ahead and find the slope. M equals x1, y1, x2, y2. So 8 minus negative 4. Let's go ahead and change those, make it positive. And then 2 minus 2. So we get 12 over 2 minus 2 is 0. Now this is what I want you to notice, that 0 is in the denominator. It's on the bottom. And when that happens, the slope is undefined. You could try to put that in a calculator, and it will tell you error in your calculator. You cannot divide by 0. And that's one of the rules of the foundations of math, that you can't divide by 0. That's the reason this is undefined. It's impossible to put that in a calculator. It's impossible to get an answer for 12 divided by 0, 12 over 0. So it's got an undefined slope. Now we're going to graph those real quick. You don't usually have to do this. You're just going to have to find the slope and tell me it's undefined. But I want you to see what this line looks like. So let's plot these. 2, negative 4 is down here. 2, 8 would be way up here someplace. And we're going to connect those two. Because I go a little off. Connect those two. And when we connect them, we get a vertical line. That's what I want you to see. That if you have a vertical line, the slope is undefined, and the vice versa too. If the slope's undefined, then it's a vertical line. Okay, so make a mental note of that. Vertical lines have an undefined slope. Let's look at the other one. Our other example here: 3 negative 1, negative 2 negative 1. I want you to notice something here too. Notice that the negative 1's are the same in both. It's different from the first example, because in the first example the x's were the same. Over here, the y's are the same. Let's go ahead and find the slope. x1, y1, x2, y2. M equals, y2 is minus 1, minus, y1 is minus 1. Change those signs, so it's really negative 1 now, plus 1. On the bottom, we have negative 2 minus just a 3, not minus a negative 3, just 3. So on the top, we get 0, and on the bottom, we get negative 5. Now, this one will reduce. This becomes 0. All right? And that's important. Whenever 0 is in the numerator, our slope will reduce to 0. 0 in the denominator, it's undefined. 0 in the numerator, it's 0. Now let's graph these so we can see what it looks like. We've got 3, negative 1, negative 2, negative 1. We're going to connect those, and we get a horizontal line. Alright, and that's important. That's what I want you to see. So, horizontal lines have a slope that's 0. Okay? We'll recap this bottom part real quick. We said an undefined slope will have 0 in the denominator, and that's going to be a vertical line. A slope that has 0 in the numerator is going to reduce to 0, and that's a horizontal line. Alright? Your slope formula, way up here, m equals y2 minus y1 over x2 minus x1. That's important. And then if you've just got a graph, if you're going to count the slope, it is rise over run. Make sure you understand all that, and those are your notes on section 3.3 for slope.